Good day everyone. In today's class, we're gonna go over introduction to summation formula. So where the summation is denoted by sigma, which is here. As you can see, we have about 5 properties here, 5 formulas. Okay, so the first one, the value of I is from 1 to n, and k here is constant, where we have that to be kn. So the second one, we have I to 1i, so the formula is given to be n plus 1 over 2, and the like. So let's start from the first one, okay, and consider examples if this is actually true, using some examples to check that. Okay, so the first example we're going to consider here is examples. Okay, so the first one, let's consider summation I from 1 to 4, then we have 8. Okay, so normally if you want to find the value of this implies that you need to take sum of 8 in 4 places, which is 8 plus 8 plus 8 plus 8. All right, so by the time you add this together, this will give you 32. Okay, so from application of the first rule here that we have here, that whenever you have I from 1 to n, you're gonna have kn. So that implies that for you to solve this, where you have I from 1 to 4, then you have 8 here. This can be written as 8 times 4, and this will give you what? 32. Okay, so that's the first example there. So let's consider another example on this. Let's say we have I equals 1 to 4 again, then let's say we have 5 here. Okay, so what this means is that we're gonna have 5 in 4 places, and we take the sum, which is 5 plus 5 plus 5 plus 5. So this will give us 20. Okay, so using the first formula now, this can also be written as I equals 1 to 4, then we have 5. So this is gonna give us what? 5 times 4, and this is 20. Okay, so that is the first thing. So whenever you have constants, sum of constants from 1 to n, so the formula, the result is going to give you what? The product of that constant and what? And the last value, which happens to be n. Okay, so let's look at the second formula that we have here, which is I from 1 to n I. So the formula here is given to be n in bracket of n plus 1 over 2. Okay, so what this means is that, let's say we have I equals 1 to n I. This implies that sum of consecutive numbers, that's the meaning. Okay, when I is 1, you have 1 here. When I is 2, you have 2. When I is 3, you have 3. So the process continues, then where the last number here is what? Is n. And sum of this, we are given that the sum of this value is going to give us what? n plus 1 over 2. Okay, there's a proving for this, but this tutorial is not meant for that. All right, so let's consider example on this. Okay, consider something like this. I equals 1 to 5, then we have I here. Okay, so what this means is that when I is 1, you have 1. When I is 2, you have 2. Then 3, 4, and what? 5. Okay, so when you take some of this is give you, this is 3, this is 6, this is 10. 10 plus 5, that's 15. So this is gonna give you 15. So let's check with the given formula whether we are going to get 15. Okay, so from the formula where you have I equals 1 to n, we have that to be n plus 1 over 2. Okay, so in a case where you now have I from 1 to 5 I, so the difference here is that the n here is what? N is 5. So let's make n to be 5 here. By substitution, you have 5, then 5 plus 1, 5 plus 1, then over 2. Okay, so this is 5 plus 1, that's 6, then over 2. So this is gonna give us what? 15. You can see we actually obtain the same results here using these two methods. Okay, so whenever you are given question under this, it is advisable to make use of the formula we have here, depending on the nature of the question. Okay, So let's consider examples that apply with question 3 with the formula 3 here. Okay, and what we have there is summation I equals 1 to n, then we have kn. So where k here is constant, sorry, ki. So where k is constant, this implies that we can factorize k out. Then we're gonna have I from 1 to n, then we have I. And of course we have formula for this already, so which is n plus 1 over 2. Okay, so example on this. Okay, let's consider I equals 1 to 4, then we have 6i here. So ordinary 6 here is constant, which can be written as 6 summation I equals 1 to 4, then we have I. Okay, and don't forget we have formula for this to be n plus 1 over 2. So by the time we make the substitution, we have n plus 1 over 2. So where n here is what? N is 4, because the last value here is what? Is 4. Okay, so let's substitute n to be 4 here. So we're going to have 6 times 4, then 4 plus 1 over 2. Okay, so 2 in this place 1, 2 in this, you have 3. So 3 times 4, that's 12, and 4 plus 1 is what? 5. And this is going to give us what? 60. All right, so that is that on that. So let's consider more questions on this. Okay, what if you have something like this? Let's say I equals 1 to 5, then let's say we have 7i minus 3. Okay, so this example is a combination of the first and the second formula we consider. Okay, so we're going to make use of the first formula and the second formula for you to solve this question. Okay, so first thing to do here is to split what you have here, okay, by rewriting it to be in terms of I equals 1 to 5, 7i, then minus I from 1 to 5, then 3. Okay, and of course we said 7 here is constant, which can be factorized, and we have 7 in brackets summation I from 1 to 5, then you have I, minus I equals 1 to 5, then you have 3 here. Okay, so don't forget we have formula for this, and the formula is given to be n plus 1 over 2. All right, and of course this is constant, and I told you whenever you have constants now, the result, when you have sum of consecutive constants, that means the result is going to be what? The product of that constant with the what? The number of constants they're expected to have. So this is going to give you what? 3n. So where n is what? Where n is 5. Okay, so let's make substitution for n to be 5 here. So by that, you're going to have 7 times 5, then 5 plus 1 over 2, then minus 3 times 5. Okay, so from here 5 plus 1 is 6, so 6 divided by 2, that will give us what? 3. So you have 7 times 5 times 3 minus 3 times 5, that's 15. So this is 7 times 15 minus 15. So 7 times 15 minus 15, that's 6 times 15, and this is 90. Okay, so that is the result for this given question. So the result here is what? Is 90. Okay. Okay, so the next example I'm going to consider here is this. I equals 1 from 1 to 8, then 9i plus 7. Okay, so we use the same process we used in solving the last question here for this as well. Okay, so the first thing is to rewrite this to be in terms of I from 1 to 8, then 9i plus summation I equals 1 to n, then 7. Don't forget I told you this sign is called sigma. Okay, yeah, so looking at this, you can see here that this 9 here is constant, which can be factorized, and you have 9 summation I equals 1 to 8, then I. Okay, then plus I equals 1 to n, then you have 7. Okay, so don't forget we have formula for this already, which happens to be 9 n plus 1, then over 2. Okay, plus this 7 is constant, and oh sorry, the value here is 8. This is 8, don't forget that. So this is sum of 7 in 8 places. So what that means is 7n. So where n is what? Where n is 8. So let's make substitution for n to be 8 now. So from here you will have 8, then 8 plus 1, then over 2, then plus 7 times 8. Okay, and again you're gonna have 9 times 2 in this place is 1, 2 here you have 4, then 9 plus 1, that's 8 plus 1, that's 9, and 7 times 8. Okay, so this is 9 times 4 times 9. That's going to give us, let's just say 9 times 9 is 81 times 4, and again 7 times 8, that's 56. Okay, so 81 times 4, I think that should give us 324. 24, then plus 56. So we're gonna have the final answer here to be what? 380. Okay, so that is the solution to the given problem. So in this class we only consider the application of the first, second, and third formula we have here. So in next class we're going to consider examples on the fourth and the fifth formula we have here. Okay, so don't forget to like, comment, and subscribe. Thank you.